Hey, thanks for tuning in. I'm John Celentano, Inside Towers business editor and managing director of Inside Towers Intelligence, our quarterly market analysis publication. This is your Intelligence Market Minute. Today, we're looking at the market for private wireless networks. Well, why a private wireless network? It's a dedicated localized wireless communication system designed to serve specific needs of an organization. These could be enterprises, government entities, or education and industrial campus environments. The private networks are reserved for a particular company or institution, generally confined to a specific geographic area. There are a number of benefits, certainly exclusive use, and that can be customized, control and security of communications and data, reliable connectivity that can scale, achieving operational efficiency such as OT and IT integration, and ultimately control of lifecycle costs. So what makes a private network private? Well, first of all, we have dedicated spectrum. This could be owned or leased. Private organizations have acquired or leased spectrum licenses used in 4G, such as low band 700 and 900 megahertz, and mid-band 1800 and 1900 megahertz in AWS, and 5G mid-band spectrum such as 3.5 gigahertz CBRS, both licensed and unlicensed. Private networks also have dedicated infrastructure that, again, can be owned or leased. And certainly there are dedicated devices that are either assigned by the organization or they'll program the user's own private phones. You can bring your own device. If we look at the layout of the network from an infrastructure point of view, a private network has the same infrastructure elements as a public cellular network: a RAN, a core, a backhaul, and with some type of network operations center. A RAN can be a mix of macro cells, small cells, and hotspots or access points located strategically throughout a campus or industrial site. RAN signals are backhauled to and from a dedicated 3GPP compliant 4G or 5G core, which manages traffic on the private network and interfaces with public or private clouds and the public cellular networks. A CBRS is a specialized private network version with 3 tiers of users. The incumbents are U.S. Navy radar stations. There are priority access licensees and unlicensed general authorized access. Radios operating on the CBRS spectrum are called CBRS service devices, or CBSD, that are administered by the Spectrum Access System, which manages spectrum allocation and prevents interference among different CBRS users in the same area. A custom core is the interface between the CBSDs and the SAS and connects with both public or private clouds and the public MNO cores. Devices can be programmed to operate on the network. Newer mobile devices are already CBRS capable. Every smartphone comes with a mobile subscriber identity number for each public cellular carrier and its corresponding authentication code. Smart devices can be programmed to operate on a specific private network using eSIM apps that allow users to connect to the network but does not allow unauthorized user access. So private networks are finding their way into a number of vertical markets. In manufacturing, a good example is Airbus, that has deployed private 4G and 5G cellular networks in its massive airplane factories in Europe. Chevron has deployed a 700 megahertz private LTE network in the Gulf of Mexico for drilling platforms and shipping operations. Bell Canada provides Newmont Goldcorp, a gold mine in Canada, with a private 4G LTE network for above ground and underground communications. Ameren is a major gas and electric utility in the Midwest that has deployed a private 4G LTE network using 900 megahertz leased from Anterix. AT&T provides DFW Airport in Dallas with a 5G Wi-Fi 6 comprehensive wireless platform for critical airport operations. And Carnegie Mellon University in Pittsburgh is partnering with Crown Castle to deploy a private 5G CBRS network. So there's 3 main business models under which private networks operate. On the left, the enterprise owns and operates the network and incurs the CapEx and OpEx. Hybrid deployments are a mix of owned and shared spectrum and infrastructure depending on applications and users. On the right, the MNO owns and operates spectrum and infrastructure but offers dedicated and custom services more and more through network slicing. So if we look ahead at what the size and growth of the market is, we're going to look at the U.S. private wireless network market out to 2029. The problem with forecasting private networks is that they are one project-based versus public network year-over-year investments. Every network is different, even within the same vertical, and they're all highly cost sensitive. So it's hard to know the exact number of private networks in the US as a start point. We have that the FCC estimates around 400 5G private networks in service. So if we look back and add in what may have been deployed in the 4G era, we think it's probably double or maybe even a little more than that number. And we're looking at it under two scenarios. Under our optimistic scenario, we assume that the economy remains healthy, interest rates are low, and capital is widely available. There's broad user demand and there's attractive ROI in these deployments. There's an adequate product supply at competitive prices, and the market grows at a 21% CAGR to 2,100 systems by 2029. Under our pessimistic scenario, the economy slows, interest rates are high, capital is scarce, there are only selective deployments, and the ROI tends to be soft in these cases. There are long lead times for products and prices are high. Under this scenario, the market grows at single-digit CAGR to about 1,100 systems. We think a more likely scenario is that the market doubles in 5 years to about 15 or 1,600 systems. So there you have it. Please email me directly with any questions or comments on this presentation. Visit our website for more information or to subscribe to Inside Towers Intelligence. Thank you for joining us today.